Check, check. All right. Thanks to everyone for coming this afternoon. I've been giving these talks for 10 years, and I think every time I draw the talk that's right after lunch, so I'll try to keep us all awake. We're giving a talk today on delivering a secure and fast boot experience with UEFI, and there's going to be a lot here around the new firmware standard, UEFI, the Unified Extensible Firmware Interface. And we're going to go ahead and keep questions. Since we have a full room, we'll go ahead and keep questions till the end. So we'll try and get through this in about 45 minutes, and then we'll have about 15 minutes for Q&A. So on our agenda today, we're going to start with what's great about this new boot experience. What are we doing with Windows 8 and with this new firmware paradigm that's really pushing the platform forward? And then we're going to look at security and what's really critical about security and why UEFI is important. If there's one reason why we're making a big push in Windows 8, it's the cool stuff is the experience, but if there's one reason, it's really security, and we'll go into that in some detail. And then towards the end, we'll talk a lot about design guidance, what you need to know, what you need to understand, some of the basic fundamentals of firmware and of UEFI. So hopefully you'll leave knowing how to prepare for Windows 8 and how to prepare for UEFI, and you'll become somebody who can inform others of what we're doing, what the motivations are, and why it's so cool. With UEFI, the boot experience is fast, safe, and beautiful, leading to higher customer satisfaction and opportunity for product differentiation. So it's a win-win for everyone. You know, we talked today, you've heard about reimagining the operating system, we're reimagining applications. We're now reimagining firmware, and it's been a very long time. You know, we've been on the BIOS standard since 1980 with IBM PC PC Advanced Technology Architecture. We've made great steps forward in hardware, great steps forward in OSs. Really, until now, we haven't really made a great leap forward in firmware. So let's start with improving the boot experience. And we'll start with what we experience today, which is in some ways much like what we've been experiencing for 30 years. You post your system, and it spends several seconds sitting there at a black screen. And much of it is not decipherable. You might have an OEM branding experience there, but you have a bunch of these function keys, and they're different in every system. There are security threats, and this is kind of a silent threat. You don't realize about it, but we'll talk about that more later in the security section. And there really is no connection between the OS and the firmware. You know, I've talked to OEMs who have firmware engineers or support engineers who've been on a call with a user where they've gone through boot 5 or 6 times trying to get them to hit that function key at the right moment, and they can't get there. It's just confusing. The look and feel of the menus, you know, because we have this dependency in BIOS on the VGA driver, everything comes up in low res and looks terrible. It really looks the same way as it did in the 1980s. Finally, and this is a big point, and we'll get to this later as well, with BIOS, there is simply a boot disk size limitation at 2.2 terabytes. They are shipping 3 terabyte disks today. So without trying to somehow re-architect BIOS, that forces us forward. That forces us towards UEFI. And this is because BIOS has the master boot record, the MBR partition type for boot partitions. UEFI supports the GUID partition table, or GPT method. And that allows us to boot to very large disk sizes. So we're reimagining the boot experience, and we're reimagining it both with UEFI and with work we're doing in the operating system. Startup and shutdown, you know, you'll hear a lot of talks today around always on, always connected, and how, you know, ideal experience is this Apple-like experience where you have the system that never really goes off. You know, there will be a lot of PCs like that, but the truth of the matter is the telemetry we see tells us that a typical user will reboot their system 1 to 2 times a day. You know, across the Windows ecosystem, you don't want to think about it, but it's hundreds of millions of times a day throughout the world that people are rebooting their PCs, and they're going through this experience. It's also how many consumers judge their PC performance. If you go into Best Buy and you pick up a laptop and you hit the power button and you have to wait for 20 seconds for the thing to be bootable and usable, you know, it doesn't matter to you if how much memory it has or how fast a processor it has. It's really a negative impact on perception, and it doesn't have to be that way. We're also heavily dependent on firmware. This is a Windows and the ecosystem kind of talk. You know, I'm speaking for myself and the Windows team, but I'm also speaking for people in the UEFI organization, people in the TCG, the Trusted Computing Group, the OEMs, Intel, AMD, ARM. You know, we're all in this together. It's something we can only do together. So the new boot experience should be fast, should be tailored and beautiful, and of course, a result of this combined effort. So let's look at what we're doing for speed. And I've seen some press reports already where they kind of blankly talk about UEFI means fast boot. And it's not just that simple. Really, if you look at the post section here, you know, that's what's happening in the firmware, in the BIOS, whether it's UEFI or legacy BIOS. And there are lots of reasons why post takes a long time. You need to post so you can show your OEM branding. You know, if you post in 2 seconds, your screen might not even come on. You might not even see the logo. You need it for those function keys. And there's some other reasons, but the nice thing is you could make a BIOS system boot very fast, but you still have those reasons to keep it. What we're going to show you today is with UEFI, we can solve all those problems for you. So you can get a system posting in 2 seconds on an SSD system and greatly reduce that first box. Secondly, if we look at Windows 7 and we go to the OS side, we spend a lot of time in OS initialization. We tear down everything on shutdown, and then we reinitialize the kernel, all the boot drivers, all the OS services, and completely restart the system on every boot. And it's happening, you know, hundreds of millions of times a day. And then we get to the Win logon screen, and we see the spinning donut going on for a bit longer as we're initializing apps and services. That's something else we need to focus on. So with Windows 8 and with UEFI, we're getting to very short post times, and we'll demonstrate that a little bit later here today. Then what we do is, because on shutdown, if you choose to shut down a Windows PC, as I did here earlier on this guy, we shut down all the user application, all the user state, and then when we get to what we call session 0, we get to this core OS state and OS services, instead of tearing all that down, we write a small hyper file to disk. And that allows us on boot, to have a very quick hyper file read where we read back all that state, initialize devices, and then because we've already started many of our OS services, we have a shorter service and app initialization time. We're also working with third-party to conventional app developers to let them know you don't have to have every app be boot start all the time. And the new app model also addresses this. So we're continuing to work on that last green box as well. It should look and feel like a regular shutdown and boot. It's going to be the default experience for users on Windows 8. And really, you get this experience even if you're using BIOS, a traditional BIOS system. You just get a longer post, but you're still going to get the quick hyper file read and device initialization side of this. So it gets better with Windows 8 and BIOS. It gets great with Windows 8 and UEFI. So we talked about the problem of showing the OEM branding moment. You know, if you're posting in 2 seconds, you know, you're barely going to see the OEM logo, or maybe you're not going to see it, depending on what kind of display you have. So in Windows 8, OEMs can describe to us in an ACPI table where their OEM logo is located on the disk. And then what we'll do, and you'll see this in a moment, we'll take the OEM logo and display it for them during the OS portion of boot. So as we're resuming, as we're coming up, and we're already loaded the Windows Boot Manager, we're actually displaying the OEM logo, and it still looks like a post screen. Another thing that's very important here is we talked about how BIOS looks crappy because of VGA. With UEFI, it supports the Graphic Output Protocol, or GOP, or GOP. And with a GOP driver, you can post in a high-resolution mode. And this means that you can pull up in native panel mode or high-resolution mode and have a single experience. And then when you make that final single transition to the desktop, you don't mode switch. You stay at the same resolution. Ideally, this is a seamless experience and very fast.
How about the jingle?
How about the jingle?
Can you play an audio
If your BIOS plays an audio, okay, the question is what if an OEM wants to play a jingle while it's posting? I'm sure that's possible in firmware, but you're going to have a very short window because it's going to be, we're looking on an SSD system of a very quick 2-second post. We can talk more about that later. Okay, so let's try the demo here. So the first thing I'm going to do is I've got my demo system here. This is an HP 8460p. You can buy these in the market today, but they come standard with a BIOS interface. We've been working with HP to put a prototype UEFI firmware on here that we're developing for eventual shipping of products. And one thing I'll say about the firmware is this is really intended to be the type of firmware that we expect to go to market. It still has the Intel vPro stuff in it. We're enumerating USB. We're doing a lot of things that you'd expect in a go-to-market firmware. It's not just a demo prototype type of firmware setup. So I'm going to shut us down here. And as we shut down, we went ahead and wrote that Hyper file to the hard drive. And then just to show you we're in a zero power state, and do something risky here. I'll go ahead and remove the battery. Okay, they believe me. Stick it back in. I'll put power in here just so we can see it better. And as I hit the power button, let's go ahead and 1, 2, 3, 1001, 1002, there's your HP logo, 1003, 1004, 5 or 6 second boot up time. And we did have a little bit of a video driver initializing issue there where you had a bit of a switch. We can work on that. I'll go ahead and hit shut down now again. Again, we're shutting down, writing the Hyper file, and we're off. So I'll walk us through this one more time. Okay, power on, posting. Display comes up, and you see the HP logo, but we're now in the OS at the end of that. And then a transition to the desktop. And I should add, it's usable. So that's a great experience. Okay, so we talked a lot about what's new and cool in the boot experience. But earlier I said if there was one reason why we had to push for UEFI, it was really around security. And there is a term called secure boot. This is really an industry term. It's between OS manufacturers, the UEFI organization, and the TCG, or Trusted Computing Group. And it's a standard set up such that you can boot a system and make sure that you have a secure, trusted handoff between the firmware bootloader and the OS bootloader. And that is critically important if you start to look at some of the coming threats. There are these threats called boot kits or rootkits. And today they're pretty sophisticated attacks. A good example is Stuxnet. The Stuxnet attack on the Iranian industrial computing facilities. They actually had rootkits on the Windows PCs that were used in that. And the reason they had rootkits is if you have a rootkit and you can load first, you then have privileged access to the system and you can cover your tracks. So you can have all the latest anti-malware software, you can have the latest Windows updates. But if somebody got hold of your PC and they put one of these things on there, or you fell victim to some kind of phishing attack where you decide to download some software and reboot, you could go months or years and not know that everything you're doing on that PC is being sent remotely to some criminal organization. This is a very, very frightening type of threat, and it's something that could sting me or you. It's something that we really don't feel we can ship Windows 8 without protecting the end user from. And it says here that often the only fix is to reinstall the operating system. Even that's not true, because you can have a firmware bootkit, whereas you reinstall the operating system, and then the firmware is still infected. And an example of where that's used for good, actually, is with, I say that slightly tongue-in-cheek, is with your LoJack type of software. You know, if you use a product that we support with CompuTrace and your laptop gets stolen, somebody can put a brand new operating system on, but they inject a binary during boot, and that allows us to track down that laptop still. That's a bootkit. We're working with CompuTrace on a method for doing that in a supported fashion where we have signature validation in the future, but that's an example of a bootkit that exists today on Windows 7. With UEFI and Secure Boot, we're going to harden that boot process to make sure that there's a chain of trust from the firmware all the way through to the boot environment. An important thing to note here is Secure Boot doesn't require a TPM. So this is intended for even the lowest end consumer systems. This is something that does not require a trusted platform module. So let's look at how this starts. And this is really the full look. This first part is what we call Secure Boot. And that is where we post, and then Windows checks the signature on the firmware, and UEFI checks and makes sure we have the right boot manager. If the firmware is not okay, we go to Secure Boot remediation and recovery. We might see if there's a firmware update that the user needs or do something to make sure that we can go ahead and get the system going again. If the boot manager has been corrupted or is found to be malware, UEFI actually has a standard mechanism built into the spec where they'll keep copies of the boot manager, known good copies, and they can replace a bad or compromised boot manager, then we can repost and boot again. We also check and make sure during the boot process that all the boot critical drivers are okay, that the NTOS kernel hasn't been compromised. And if anything goes wrong with these OS components, we have a pretty good system set up for restoring the system through Windows RE, Windows Recovery Environment, reinstalling the operating system by booting to your network, contacting support, etc. But we get through all this, and just to make sure, we have a program with the anti-malware vendors where we make sure that the first non-Microsoft driver to load on your system is the anti-malware driver. So again, we have that chain of trust and make sure nobody gets in under that anti-malware driver. Then we can go on to Windows Logon, start launching our third-party boot critical drivers, applications, etc. Now, if that's not enough for you, and you have a TPM, there is something called measured boot. This will slow down your boot time. That's the one thing I'll say about it. But financial institutions, government, security organizations can take it a step further and measure every component of the boot process, and measure that against that hardware component, that trusted platform module. And there's a good talk on this we'll reference at the end here. So absolutely critical. We felt we couldn't, we really felt we couldn't put Windows 8 out to market without ensuring that almost every system out there has this level of protection. So we talked about boot protection. UEFI, because we now have access to this new interface, there's a lot more we can do with it. And here we're really talking about is data protection. With UEFI and Windows 8, and a TPM, you have native support for encrypted hard drives. And what that means is, as we expect encrypted hard drives, which are hard drives that can encrypt themselves quickly and have very little CPU overhead on the system, we expect that to become a commodity type of item in the Windows 8 timeframe. Everybody will have one. Every drive you buy will eventually be an encrypted hard drive. With Windows 8, it works seamlessly with BitLocker. All the tools, all the key management tools and everything you have today works seamlessly, and you get all the advantages of encrypted hard disk drives. Now, if you're managing an enterprise and you have a bunch of desktops that are connected with an Ethernet cable, or you have a bank of servers that you really want to have great data protection on, and you want to have that data BitLocker protected, today you have a big problem. Because if you try and remotely reboot all those systems and they have BitLocker, you have to send a tech in there and hit the PIN code every time you boot up. With UEFI and DHCP, you can store those PIN codes on an Active Directory server and remotely reboot those systems, and as long as they're connected to your network, they'll just reboot. However, if somebody were to back a truck into your facility and throw a bunch of those boxes in the back of the truck and drive off-premise, all that data is still protected. So this is one where, you know, a lot of our pitch here and our requirements are around client. This is one where I think if data protection becomes important in the server environment, this suddenly becomes a must-have for server as well as for client. So those are the key points on security. We're now going to back up a bit and go into some of the nuts and bolts around UEFI. And we'll start with some of the design guidance, and we'll just look at the evolution. Back in the 1980s, when BIOS started, you basically had a legacy BIOS that would boot into BIOS mode and hand off to the OS loader. That was prior to 1998. Can anybody tell me what happened around 1998 in the firmware world? What was the next step? Next step was? We've got it. He almost said it.
It was non-volatile RAM. It's ESD or something like that. It would store the plug-and-play IPs.
There were some things like that, and you had advanced power management, but that was all BIOS controlled. But what the big drive was in 1998 was ACPI. There suddenly became a real need during runtime to have communication between the operating system and the hardware such that you could control power states. You could do things like turn fans on and off, put devices into lower power states, put the system into different power states in a standard way. So ACPI is something we're now on the 5th revision of. 1.0 came out around 1998. And that was a real evolution in firmware, but it was all runtime. We're still booting into legacy BIOS. Then Itanium comes around. And because Intel couldn't use BIOS, BIOS is only for x86 and x64. So they had to come up with a new firmware interface called EFI, Extended Firmware Interface, that became UEFI. And because it was based on good, sound architectural principles, it started appearing in common PCs, but under the covers. And then UEFI used something called the Compatibility Support Module, or CSM, to mimic BIOS mode. So the OS still sees BIOS mode interfaces, but under the covers, we're already using UEFI. Most of the laptops today, most desktops today are this type of system. What we're looking at in Windows 8 is flipping the switch one more time, and now exposing UEFI fully to the operating system. You know, we've supported this since Vista, but we haven't really taken advantage of it until now. And we can now use the UEFI runtime services. And we can do this to do things like, you know, we talked about those function keys that you have to hit during boot, and that's one reason post needs to take so long. Now you can start to boot and hit the escape key too late, and the OS will send you to an OS boot options menu, and from there you can go ahead and boot back into the network or boot back into your BIOS menu. So now users have a single key to think about, and they have a standard way for going from an OS menu back into a BIOS menu. So it takes away another one of those reasons for having a long post. Also, all the security features we talked about, they all rely on this communication between runtime services and the OS loader and our APIs. So this is really what starts to open up a whole new set of opportunities for both the OS and for firmware. This is just a really high-level look at some of the advantages. We talked about the architecture being agnostic for UEFI. Every ARM system is UEFI. There is no BIOS for ARM. That's a great example right there. BIOS was based on 16-bit real mode with UEFI. You're 32 or 64-bit, depending on what type of UEFI core you have. We have that boot partition limit again. The limitation for MBR, master boot record, is 2.2 terabytes for your boot disk. We already have 3.5-inch disks today shipping at reasonable prices. They're 3 terabytes. For that, you need GPD, or the GUID partition table. The limit there is 9.4 zettabytes. That's a few times more than all the information that exists in the world today. So we'll probably be a few years before we hit that limit. Runtime services, again, nothing in legacy BIOS. No driver model for legacy BIOS. Instead of a driver model, what you have are option ROMs. You've heard of option ROMs on devices. So you have a network card and it needs to send some information to the user at boot time to boot to the network. That's done via an option ROM. With UEFI, you can write a UEFI driver and store that in firmware instead of having that ROM part on your device. And we got some bonus material in this last one. Post graphics, VGA on BIOS, now we have that graphical output protocol. New systems like these ARM systems, they don't even have VGA support, which is interesting because Windows 7 had a dependency on VGA. We had a dependency at boot, and we had a dependency when the system crashes and you get the blue screen. So we removed that dependency, we had to, for the system on a chip. And once we removed that dependency, we have some bonus material here because once we removed that dependency, we actually came up with a new, who has seen the new blue screen? Has anybody seen the new blue screen? Have you seen it in English or in another language? We can actually do it in another language. We'll show that here. We'll show that to you here at the end. Nobody else has seen that. You're the first ones. I looked online. I looked at all the presentations. You're going to be the first ones to see a picture of the blue screen in a foreign language. I don't think that's been disclosed yet. So this is a quick slide to look at some of the effort we're making with the industry around certification for UEFI. New Windows 8 client requirements. Windows 8 client systems must be certified in UEFI mode. We really want every system shipping to ship into UEFI mode and to have secure boot enabled. We want that level of security for all our mutual customers. That's a big change. It's a big change for the industry. We've been working with folks like HP and Samsung and the IBVs, the independent BIOS vendors, and we've been working on this full-time for about a year, and it's a big ramp up. So there's a lot of effort going on, not just with Microsoft, but throughout the industry. You have to have a way of securely updating your firmware. Remember, this is all going to be done via signature validation. You have to have the GOP driver support for that beautiful experience that you get at boot. With that come new graphics requirements. And then post-time maximums. We really want to get that post-time down. So for example, in an SSD system, we want the post to be in 2 seconds or with a TPM 2.3 seconds. And that HP system we showed you is getting right around there. So it's an aggressive goal, but there's no reason why every system can't have that type of boot experience that we just saw. The BitLocker features are if implemented, so there's some, we want it to work right, obviously. This is really all the high level. Those of you who are OEMs, there's a whole bunch of other requirements underneath this, but these are the basic requirements, and we have tests and programs to help work with the industry to achieve this. So as a recap, you can see what the motivations were. Hopefully you've learned a little bit about the architecture and where we are moving forward. Before we go to Q&A though, I promised you, here are a couple related sessions. There's a TPM session. And if these have already occurred, you can find them online. All this is being recorded. We also have a session on the Windows certification program, improvements to the logo program. There's a lot of UEFI content in there. And then I promised I would show you, we didn't just blue screen, but this is the new blue screen. Hari Palaka from my team, this was actually his idea. This was a, hey, we removed this dependency on VGA, why don't we do something with it kind of idea. First managers he took it to, shot it down, he kept at it, so Hari here is responsible for this experience. Hopefully it's a little bit more humbler, a little bit, we do care, the system crest.
Where's the hex?
And there's no hex code here. And I think, and here's the one in foreign language, and you're the first ones to see this. Looks like there was a slight bug there in Conan, but we're getting there. We're not shipping this yet. So with that, I'm going to back up to the resource slide. You can see some of the opportunities to go out and find out more about UEFI from the UEFI org. There's a great book called Beyond BIOS that was put out by Intel and some of our friends who've been working on this for so long, and just a bunch of resources up on our MSDN site as well. So thank you very much. With that, we'll go ahead and open it up to questions. And I can either repeat your question for you, or we have a microphone here in the center of the room. Yes?
So you had said that you're going to be checking driver signatures and you have to have them. Now, currently, that's been the case in 64-bit Windows 6 and Windows 7. Does that mean on 32-bit Windows 8, we're going to require the driver signing as well?
The question is, we require driver signing on 64-bit already. And for secure boot to work, you have to have 64-bit. That's the first part of that. Now, are we going to support? Are we going to push for driver signing in 32-bit? And I know our security team is pushing for that. I'm not sure what the POR is. So we feel so strongly about security that we'd like to have signature enforcement on 32-bit as well. You have my contact information. I'll get you an answer on that later. I know it was being discussed.
So the slide we saw that said we have to sign the drivers, the unspoken part was for 64-bit.
Yes, and
Okay.
yep. Yes, you first, and then behind you.
So who are the certificate authorities, especially before boot, and how do we handle revocation, especially before the network comes on?
Okay, so the question is, who are the certificate authorities before boot, and how do we handle
Revocations, especially before the network?
revocation? So that's a great in-detailed secure boot question, and the certificate authorities, I believe, Hari, you don't remember who the?
I think they're basically the same security authority that
Yeah.
support Rainbows right now.
Yeah, I think things like.
But if you think about the ELAN, which is the early launch anti-malware drivers, they might only support a subset of Rainbows certificate authorities. I don't know exactly what those are.
Yeah, so
If you go back to the link,
I think it's.
So what's the search?
Not WCL certs. There are things like your typical certification authorities for both firmware code and for OS code.
So how do we handle revocations then before the
yeah, the second part of the revocation basically is, you're right. So before the system starts up and there's no network, you can't actually revoke anything. So that's where the second part of Ari's slide, which was the measurement part, comes in. So at that point, you start measuring your device drivers and the hashes and signature checks and all that, and it turns out that your driver was actually revoked. That's when you send it back to an attestation service, and the service can actually know that, oh, this was revoked, and so you actually have a compromised system. So the measuring tape that Ari has there, that basically helps in this scenario.
Yeah.
But a firmware that is infected, that had a trusted certificate that later becomes untrusted, there's no resolution.
So yeah, there actually is an update mechanism for us to, via Windows Update, what we'll do is if a certificate got compromised, we can use Windows Update to update the database, and there's a database in firmware actually called a KEC, and there's a white list and a black list, and we can add to the blacklist and go ahead and find if there's some malware out there that's trusted. We'll hunt it down, use Windows Update to go out and eradicate it.
And that code itself is not updatable in firmware.
Right. Right. And truthfully, there is about an hour we could go into how secure boot works. But I'll give you my card later, and I'll give you some contacts. I'm speaking from the UEFI side. There we have a security team that was very focused on secure boot, and we just couldn't have 3 sessions, so we put it all into 1 session. Okay, behind.
So how does this work with like dual boot and the virtual machine?
So the question is, how does this work with dual boot and virtual machines? And you're talking about how to secure boot.
Yeah. How does a machine work when
Yeah. So if you're dual booting, it depends on whether you're dual booting into another trusted operating system. One discussion we're having is this first firmware OK, boot manager OK handshake. We can't have a version of that works for Windows 7. Windows 7 doesn't have the ability to check firmware, but firmware can check and make sure there's a signed Windows 7 bootloader. Truly, right now, today, if you want to have secure boot and you want to dual boot Windows 8 and Windows 7, you need to turn secure boot off in firmware. We're thinking about having a way that you can go ahead and make that work, but that's not POR yet today. Next.
You mentioned the ability to check the firmware and boot manager without TPM. How does that work?
So the TPM is the measurement that's made at the end. If you want to go ahead and measure every component. Secure boot, as a standard with TCG and UEFI, works without needing a TPM. So the signatures are kept in a database in firmware, and they're updatable through secure mechanisms. But you don't need a TPM to do any of that initial signature validation, just like you don't need a TPM to do driver signature validation today.
That database is not accessible?
That's more of a secure boot question. I'm not the secure boot expert, but let's hope so. Okay. Right here.
We are providing a device which is integrated in the platform. We are providing also the UEFI driver for it. I have two questions. One is, does the UEFI driver need to be signed, or only the BIOS as a whole is signed? One question. Second one is, can you give me some pointer how to access the UEFI runtime services to Windows?
The UEFI runtime services. Okay. So there's two questions. One is you have a device that has a UEFI driver, and does that driver have to be signed, or is the BIOS signed as a whole? And I think the question is either way works. As long as the driver is part of a signed image, it should be okay. But if it's not, then the driver itself has to be signed. And the second question was where can you get more information on runtime services? And there I'm going to refer you to the UEFI specification. It's up on the UEFI org site.
The access to Windows, not
Oh, okay, so how?
we know how to do it on our side,
Uh-huh.
but we don't know how to access it through Windows.
So you want to have access to Windows APIs that access. I believe those are private APIs, but we can talk about that later if you think there's a legitimate reason for using. So for us, all our runtime APIs, all our calls in. For this actually opens up a really interesting topic, because we talked about having this Windows boot menu that would then call things like boot next and say, hey, on next boot, I want to boot into the network. People might want to write applications that take advantage of those same APIs. POR in Windows 8 that's not going to be customizable. That's going to be private APIs that only we use. We are thinking moving forward, maybe in the next operating system release, of having something much more extensible, where an OEM can have a really rich boot option menu, but have it from the OS, where we read some data, boot into the OS, and then say, hey, anything I could do in my BIOS menu before, now I can do in my OS boot menu. And it's customizable by OEM. To me, I'm thinking more forward to beyond Windows 8 when I think of that, but it's very possible. Yes?
You might suggest BCD edit, because one of the steps you actually want to get to from the runtime services, you can get to the WMI interface to BCD edit.
Okay, so Emily on the boot team recommended looking at the BCD edit tool, because a lot of the WMI interfaces that indirectly or that redirect through the runtime services are available there. So anything that we have that is available would be available through BCD edit. Okay, right here and then over here.
So when you shut down, you write a file and then use that for a consecutive boot after that. So what happens on an unexpected loss of power and that file doesn't get written? How is that handled on the next boot?
So you're
You had this hibernating process,
Ah.
saves a file, and I'm questioning unexpected power loss before that file gets written.
okay. So what happens? The question is, what happens if you have an unexpected power loss and you can't write that Hyper file on the way down? I could just demonstrate that.
I expected boots back to a previous one or something.
That's a possibility, but if something like that happens, we actually go ahead and do a full boot. And another good example is if we see the memory map change. We know somebody's opened the lid and put memory in there or done some hardware change. We don't want there to be a possibility of a blue screen, however nice that blue screen is. So in those cases where we can detect something has changed, we go ahead and automatically do a full boot. And I was going to see if I could.
That's something new to Win 8?
And that's something in Win 8. We're being asked, and again, we're still part of the Win 8 process here, but we're looking into also having a hint the BIOS can give us. So let's say you have a lid switch. Somebody's opened that lid. hey, that's enough to tell us something might have changed. We might not be able to detect it, so we should go ahead and do a full boot. So we're even looking at having another variable, UEFI variable that tells us that happened. Not POR, but it's something that we're looking at here in the next milestone. So we'll go ahead, I'll go ahead and hold this up. If I hold it down for 4 seconds and we don't shut down by, there we did. We did a hard crash boot. And on the way back up, this should be a regular boot. And there's the HP logo, and this is taking longer. You can see we're spinning around a couple times. So this is a regular boot. This is what happened when I just did a power loss type of shutdown. And we're still spinning there, a little different experience. So still pretty fast. Yeah. But we were definitely 2-3 seconds faster with the hybrid file write. Yeah. Yes, right here.
I had a question, like if you were like in the middle of setting up a system and there's, I don't know if this is going to be, hopefully you don't have to have multiple reboots or your driver configuration or your hardware configuration may change a couple of times, in the out-of-box experience window there. Does that have any bearing on sort of the boot times you'll see, like if the user should be powering it down, after the third or fourth boot, or is there a difference between this?
No, we don't have any kind of like predictive algorithm. The question is if you're making a lot of hardware changes, is your system going to default to always booting slower because it thinks there's going to be future changes? We assume things are going to be working right. So even if you're making a lot of changes to your system, we aren't going to turn off fast start. We're going to keep fast start on. You can, however, if you're having problems, you can go in and disable fast start and choose to always do a restart in your power options menu. Over here.
Are you relying on the OEMs to decide which drivers are available in UEFI?
Are we relying on the OEMs to decide which drivers are available in UEFI? And yes, again, we're all working together. So it's us, it's the OEMs, it's the IBVs, the independent BIOS vendors. And we're also getting a lot of pressure to say, hey, Microsoft, we're going with UEFI. Can you help us talk to the device vendors about moving away from legacy option ROMs and moving towards UEFI drivers?
So do you have a minimum set of drivers you can import, for example, keyboard drivers that you use?
So do we have a minimum set of drivers we can use? And with UEFI, one example was, you want to be able to make sure your keyboard enumerates because of BitLocker. When we get to the BitLocker screen, Windows can actually call, what's it called again, Emily? Connect controller. We can make a UEFI call that says, hey, we're at the BitLocker screen. Let's make doubly sure that we have this keyboard enumerated, and we use that using Connect controller, which is a standard UEFI call. So that's another example of one of those calls we make into the system.
Another comment, particularly with regards to the keyboard, we have done some redesign so that in the cases where you need a keyboard, there is a soft keyboard available. We did not build that into the UEFI. It's not a UEFI driver, but we changed the Windows experience enough to do that. So you probably wouldn't choose to put a pin on your keyboardless tablet of sorts because entering that pin in that environment is not possible. But to get to the other menus, and if you got into a recovery state, say if you had BitLocker with TPM only, you have that all available to you. So we did realize not everybody's going to have a keyboard, and we planned ahead on that one.
Okay, so Emily just talked about different scenarios where not everybody's going to have a keyboard, so we have soft keyboard support during the boot process.
So basically, all you really need is your boot critical drivers.
Okay.
If you don't have a display device, we're in trouble. If you don't have a disk, we're in trouble.
Okay. I saw the first hand right there. And
Can you go through an example of going to there is a UEFI setup screen or something like that on that system? Hit escape and it'll go to...
I don't think we have that in there yet, the boot option screen, do we?
Yeah,
You want to go? Okay, go ahead and try. I'm going to bring Emily up, she's our boot PM. And if you've seen Emily before, she did this demo online, and there have been over 300,000 hits on YouTube.
I was not one.
Okay.
I
So Emily, if you do,
We'll look for it
if you
now.
do it over here, we can stay on the, or you gonna,
Just gonna.
okay. She's gonna work on that. We're gonna come back to that. I'm gonna hit some people in back just because I've been missing them. So back there in the back.
So in Windows 7 before, if you have checklists, sometimes it will run that in between times when you post. How does that work with Windows?
So the question is, what about check disk? If you've had a hard crash, is check disk going to come back on? And I don't know. I don't own the check disk tool. That would certainly only come on during a full reboot. But I just noticed, for example, just now and in recent builds, I haven't seen it. So I have to go check with the check disk owners and see if it still comes on. I would guess if it doesn't, there's something else to make sure that we're doing good disk validation. Does anybody else in the room know from Microsoft? Okay, sorry, I'll have to get back to you. Yes?
So what would the consequences of a buggy driver be that leaks some memory? Would that memory continue to be leaked across boots?
So that's a good question. So what's the problem if you have a memory leak, especially with a buggy driver, and then you're capturing that state over and over again, and that memory leak just persists? And that is something we need to detect. Emily, do you have a better answer for that?
It would happen across hybrid boots on shutdowns. However, restart still does a full teardown and restart. So when you actually install new updates, say with Windows Update once a month, twice a month, you're still going to be doing full reboots on all of those cycles. So it's very important to have drivers that are very high quality. We do, don't worry, 10 years from now, you're not going to be suffering from teeny tiny leaks. So.
And I have to add, we have a lot of tools around detecting memory leaks in drivers. Hopefully they've gone through the Windows validation process. You have the same problem with always on, always connected devices because you're only doing reboots rarely, usually when you do a Windows update or for some reason you choose to restart your system. So OCA is another way. We get data information around memory leaks, and then we aggressively go after those memory leaks in those drivers. Yes?
Related couple of questions. Can the user or an API perform a real shutdown?
Can the user or an API perform a real shutdown? The answer is yes. And if you type shutdown.
So shutdown.exe with this crowd, I'm guessing.
Yeah.
So shutdown.exe, there's going to be a new flag that's /full, which will then do a full shutdown. So if you use the shutdown APIs as we knew them in Win 7, it will do a hybrid boot by default. But if you add /full, you can do a full shutdown, and there's the equivalent at the API level as well.
And at the GUI, is there a means for the user to initiate that?
They'd have to turn off the fast startup functionality entirely. So you can go into, there's a new checkbox in the Power Options UI. There's a new option in the Power Options UI, little checkbox that says enable fast startup, and it's checked by default. So you can turn that off, and then you'll do a full shutdown every time. So if you're testing out a piece of hardware and you know you're going to need a full shutdown every time, you can go ahead and uncheck that box. But we didn't want to put something at the higher level UI because we didn't want users to be making the wrong choice. Why penalize them with an extra minute of their life they didn't have to spend when they don't need to?
This one. I'm going to get back to the front. I'm going to go back towards the back because I've been missing. Actually, I'm going to start back here because I've been missing this corner. In the very back first. So the question is that there's two types of TPMs. There's a firmware TPM that's used mostly on SOC devices, and then there's a hardware TPM. And for what's the required TPM for? I forgot in here. Oh, BitLocker. Either one works for BitLocker. And that's actually a much better question for the TPM talk, where they'll go into that in detail. But either one works here. I should have said firmware TPM as well, but that works here in the same manner. Yes, right here.
I assume you're supporting UEFI virtual machine environments as well. So
Are we supporting UEFI in a virtual machine environment? I believe the VM itself is a BIOS system, but you can run it on top of a UEFI system. Yeah, yeah. Back right here.
So back on the BitLocker, is it now with UEFI and controller?
Connect controller.
Connect control. Can I use two-factor authentication with smart cards for pre-boot?
Can I use two-factor authentication smart cards? That's another question for the BitLocker talk with Rob Spiger, and come see me afterwards if you need the direction to that. Either it's a video or he hasn't get presented it yet. I forget which. Right here.
So in answer to your question, should users be penalized that extra minute? I'm thinking about when you're talking to somebody over the phone, or if you've seen the IT crowd, if you try to turn it off, turn it back on, and to think that if I'm telling a user I really want them to boot because I don't know whether there's a service that's having a problem, having them have to poke their way through the control panel just sounds...
No, and the real answer there is tell them to restart. What they really want is they want to have their machine on again and they want to have it working. And restart does a full shutdown and start. And if your machine is up and running and something is going wrong and you want to refresh it, you want to restart it. You don't want to shut down, sit there for a minute, and then turn it back on. So do what you wanted to do, which is a restart, and select restart.
But it sounds like you're not refreshing any of the stuff in System 0. And it completely
In a restart we do.
Yeah, if you choose restart.
Restart is full old
Yeah.
school
But you
shutdown.
pull it out of hibernation.
Not in restart.
No.
So if you choose to shut down your system, which is your typical behavior.
Okay, so this is a new word in the UI.
So there is shutdown and there's restart. There's restart in Windows 7 as well.
Okay, I got it.
Yeah.
Yeah.
Yeah, so restart, to repeat this, restart still means the same thing as it did in Windows 7. Shutdown now still says shutdown, but what it means is we're going to do a hybrid file read during that shutdown so we can do fast start next time. But if you do a restart, you still do a full boot. Here in the middle.
Windows 8 bind to UEFI. How about now in this issue of the PC, how to upgrade to Windows 10?
So that's a good question. So the question is, Windows 8 will support UEFI. What if you ship a system now that's UEFI capable? Windows Vista and Windows 7 support UEFI. They don't support all these new experiences, but you can ship a UEFI Windows 7 system today. And then when it migrates to Windows 8, you can take advantage of all these features. What I don't recommend doing is taking a BIOS system today and then flashing new firmware on it, and then going from BIOS mode to UEFI mode. One reason is you're going from a different file partition. You're going from MBR to GPT, so you really have to reinstall your entire operating system. Another reason is no OEM is going to do complete validation on their system in both modes today. So most of the systems today that support UEFI support it in a non-supported fashion. So really, it's a lot. There's a lot of prototype firmware out there, and we really want to wait for the full OEM validated experience. In the back.
You said you're going from MBR to GPT, but UEFI still supports MBR, right?
UEFI support can read from an MBR partition, but it can only boot to a GPT partition. So everything that you need to boot is on that MBR partition, and in Windows, UEFI can't go and boot into MBR mode. We don't support that.
It should also be noted that you can, if a user chose to upgrade their system themselves, they bought a laptop today and they wanted to upgrade it 2 years from now, Windows 8 does still run on PCAT systems. The experience isn't quite as good. You end up with some flashes and stuff as you change modes, to text mode and back. But it works. It's not. We didn't forget about all the existing world.
90-some% of the systems we're still testing on in Redmond are still BIOS. So BIOS is still a first-class citizen. You just don't get all these extra features.
So did you want to?
Okay, Emily's going to go ahead and walk through the menu here. That when you hit the was this the Windows key that got you here?
So if you choose to boot your devices that you got yesterday, and yeah, you press the Windows key, it'll take you to this menu. Think of this as the equivalent of F8 in the old world. We've got some new options in this case, and as you can see, we have a new look and feel that's not 30 years old anymore. And I'm sorry, this isn't a touch device, so I can't do the fancy touching on it. But the same thing works this way, so we could continue on with our boot, but that's not quite as exciting.
Okay, so here we could do a reboot to the network, for example.
Yeah, or one of the cool things that you can do with UEFI that you can't do with a PCAT system is you could do a boot next option and choose to boot to a USB flash drive. So if you're familiar with the UEFI semantics of boot next, basically it puts it at the top of the boot order. So we now have UI that allows you to select that. So if I had a bootable USB flash drive with me, I could select this option, put it in there. We would do a connect controller, see it, and you could reboot directly to that.
Can we do this through BCD edit?
Probably through BCD edit, but I don't think any mere mortal would ever want to use that.
Yeah.
And then you also have options that'll get you into the Windows recovery environment, the reset and refresh modes. So if things were really wonky on your PC, you could get to it this way as well as from the running system. And then, of course, you could shut down from here as well.
How about to get to the legacy BIOS setup there?
Okay, so the question is how to get to the legacy BIOS setup. So if you want to get to BIOS setup, that's coming. It's not in this build.
But it's POR to have an option on this?
It is currently POR, but it's not in the build yet, yes. Right back here.
So also you used to see sometimes like boot last known good or boot from your previous registry if your registry got corrupted.
Yeah, so if you want to boot from, we used to have boot from last known good or restore your previous registry settings. All that now is part of the WinRE process. Is there a talk on WinRE?
I don't know if there is.
Yeah.
I know that there's a few things missing from this list. Part of the trick there of how do you get to it fast enough is the problem that we're still wrestling with at this point, because it's really not an elegant solution to tell somebody to turn on their machine, wait approximately 2 seconds, and then start hitting a button really, really fast. So when we have the solution to that, I'll let you know how we'll get to those options, but they are there and they are available. Unfortunately, today, if you have to get into that for some reason on your devices that you just got, you'd have to plug in a keyboard and hold down the Shift key and hit F8 at the same time, and it's really ugly. So
we have 2 minutes left here. I'm going to go ahead and I'll be out here in the hallway. If we want to continue the conversation in a minute, we'll answer about 2 more questions here, and then we'll go ahead and go out to the hallway. So I'll start right here and then go to the back of the room. Or I'll get you 2. So we'll do 3 more. Yeah. Yes?
If the system support tries to BIOS impact the Windows OS behavior, I mean the usual BIOS support CSM.
Okay, so if the you're asking about UEFI BIOS with CSM.
Yeah.
So if you're booting with a UEFI BIOS, but you're booting into BIOS mode. That's still supported, and that's what most systems do today. But what we're really pushing for as a requirement is that you boot into UEFI mode in Windows 8 for new systems, new shipping systems that ship after Windows 8 release. I'm going to hit you in the back who I've kept forgetting over and over again.
Secure boot is specified in UEFI 2.3 and 3.1. Does that mean Windows 8 requires UEFI 2.3 at least?
I'm sorry, I couldn't hear you from back there.
Secure boot is specified in UEFI 2.3 or 2.3.1. Does it mean Windows 8 requires 2.3?
Okay, so yes, secure boot is defined in Chapter 27 of UEFI 2.3.1, which is the latest UEFI revision of the spec, and that does mean that Windows 8 Windows 8 requires secure boot. So yes, Windows 8 requires the latest implementation of the firmware for systems that pass certification. Yes.
What about systems who have, let's say, UEFI 2.0 and 2.1, which is the majority of the machines out there?
So systems today that boot into UEFI mode and have 2.0 or 2.1 will work fine with Windows 8, but they won't be able to pass the certification tests for secure boot. So those systems will work fine, but you won't get the secure boot feature.
Once again, just following up on that, does that mean that for the certification, you need chapter 27, or does that mean you need 2.3.1?
And that's a good question too. You need chapter 27, and you don't need the whole thing. There's a whole bunch of stuff in 2.3.1 that's not required for Windows, and there I'll refer you to the Windows logo requirements that will be coming out more publicly pretty soon. If you go through there, we got lots of feedback that people wrote requirements that made it sound like you need all of 2.3.1. That's not true. You need very specific things, and chapter 27 is one of them. All right, with that, I thank you all for coming. It was great. Lots of Q&A. I'll be out here in the hallway. Thank you.